You should be the host again.
Yes.
Okay.
Okay, take it away.
Okay. Thank you. Thank you, first of all, for having me. I don't know this particular community yet, but I'm very excited to be part of it now for the first time. And yeah, I'm a little bit into Star Wars, and therefore let's start if that actually works here. Welcome to the Imperial database. Just arrived here, and we are requested to improve the quality of one of the applications, the Death Star user registry. And if you watched the teaser for this talk, you will probably know this guy here. And if you didn't, this guy is Darth Aurra, Sith Lord in charge of the Imperial database. And he's the one who sent me here. And maybe you expected some shiny new tech here, but the Galactic Empire uses a big relational database, which is ancient technology. So let's get this setting straight. Seriously, relational databases have been around since the 1970s and will very likely be around for a couple of more decades. So who am I? My name is Samuel. I'm also called Pessy. I'm not a tester, but just a developer. So you all might probably know a lot more about testing than I do. But I do love software quality and automated testing. And I love these things no matter if I'm working with Java, JavaScript, or if I'm working deeply inside a database. I work as a senior software developer at Smenso, a very tiny company in southern Germany. And I love to tell stories. And that's why I'm here today. So before I start, let me give you a little bit of definitions and information. When I say test during that talk, I always mean some kind of automated check. And I know that testing is a lot more than that, but for this talk, let's stick with this very, very narrow definition. And in this talk, I also want to go over a couple of different topics, and that means we cannot deep dive and we will not see a lot of code. However, since you might want to try out the stuff that we are talking about, I prepared a number of detailed examples, and you can find them at my website, developer.sam.de/test_impdb, and impdb stands for Imperial Database. So let's get started with taking a look at what we're up to. And the application we are now responsible for is a common form and table-based website. Not the most pretty one, but really, the Empire doesn't want their employees to be distracted too much. And the first questions that we should probably answer are: where, at which level do we want to test, and what should and can we test? And if we look at how such websites are often built, we have a couple of possibilities where to test. We can test the in and output of the UI directly via end-to-end or UI tests. And this might even be a good idea because it verifies the whole application. But it is also very, very costly. We have to deal with a lot of challenges like session handling, login mechanism, and all that stuff. And we also have so many dependencies that a failing test can have a myriad of different reasons. So our signal versus noise ratio is probably a bit poor. Another option that we have is to use tests that target the API level, which means, of course, less dependencies. And this approach will very likely use a database abstraction layer and therefore provide familiar programming languages and tools. It's also, from my perspective, the most common approach. We have, however, still a couple of dependencies like a running web or application server. And we also still might have to deal with challenges like authentication. And one thing is that the setup and tear down of test data is relatively complicated when we are targeting the API level. We could also test directly at the database. And the nice thing here is that we got no dependencies besides the database itself, of course. We have no interference of an abstraction layer, and we can remove a lot of noise. The data setup and tear down is also very, very easy when we are targeting the database directly. Of course, there are also downsides, but most of them are, in my opinion, due to a lack of familiarity and knowledge about the necessary tools and approaches. And there is also one thing, and that's kind of important, because testing in the database really embraces the idea of having business logic in the database. And that's something that is often frowned upon by developers, at least. But maybe we will discuss this a little bit later. I don't say or suggest here that we should only test at the database level. Each level has its purpose and has its benefits. But what I do suggest is that we at least should test at the database level. And that's exactly what we're going to do now. So what can we test in a database? There are 3 different categories that we can differentiate. And the first one is we can test the general availability of the database. The second thing is we can check for a specific functionality, and probably most importantly, we can verify and check the validity of the data. Let's start with the most important one, which is connecting to the database, because without that, we really have problems with the other things to test. And what we need here is any kind of tool that is able to connect to our database. And for this kind of checks, we get the most benefit from targeting the production database. And we can do this with any tool, any programming language that we want, as long as it is possible to connect to a database. And I have an example on the website where I use a Node.js application and the Mocha testing framework to do that. Of course, there are also general monitoring tools, for example, Nagios, or even vendor-specific ones like SQL Monitor from Redgate. And each of these tools, each of these approaches will give us some confidence that the database is generally available, which is already a pretty good thing. Once we're connected, we are not yet done, but we can run a number of high-level checks about the objects inside the database. For example, we can check if there are any invalid objects in the database. We can check if the users, schemas, and objects that we need actually exist. And we can even check if the tables and views that we have are the ones that our API actually expects. And I think these are some pretty helpful tests and some really helpful information. But how do we do that? And one really great thing about relational databases is that they are completely inspectable by SQL. You can get all the information about database structure, objects, users, even rights and roles by querying for it. SQL is your friend, and if you only remember one single statement from this whole presentation, please let it be that one. So here's an example for such a high-level check, and this pretty simple select statement will show all the objects like views, procedures, triggers, etc. in an Oracle database that are not valid. And if they are not valid, that means that they might be broken, and that again means that we might have a problem in the application, in the UI, or somewhere. And we can now run this query with the same tool that we use to check the general availability. And all we need to do is run this query, and when it returns anything, let the tool cry error. The best thing about these kind of high-level checks is that we can usually do them in production because we are not changing anything. We are not introducing test data or something. So the risk to run them in production is very, very low. Let's have a look at the second thing that we can test in databases, which is functionality. Now, what do I mean with functionality? Whenever our application interacts with the database, for example, to create a new user, there will be some SQL that is sent to the database. And in many cases, these will be inserts or updates that are created by some API abstraction layer. And that means that we need to test this functionality at the API level with all the implications that we already spoke about. Some functionality, however, might be built directly into the database. In our case, for example, we have a database view that contains all the users of the dark side. And this is very, very cool because we can actually test the relation between alignment of a new user and this very specific view right at the database level. And let's not do this in SQL, but with some kind of general description. The thing that we would like to do here is when we insert into the table user with name .veda and with alignment dark, then the select from our view vUser's dark side should contain an entry .veda. And this is a test that we can actually run without any API level integration right at the database level. Now, since we are at the database level now, we can leverage one of its features to help us with test data setup and cleanup. We can use transactions. We set up our test data, we verify the content of our view under test, and then just like that, roll back as if nothing ever happened. That's pretty cool, isn't it? And you might be surprised, but there are dedicated testing frameworks that embrace this kind of tests. UTPL SQL, for example, is a full-blown RSpec testing framework that operates directly in an Oracle database. And all test suites and tests automatically create a transaction save point, run the test, and then roll back any changes after the test is done. That's really, really handy. And let's pause here for a short moment and think about something. What if we had more of this functionality right in the database? What if our database was a module we could easily test in isolation without the added dependencies of external APIs? What if we could have a robust, testable, and fast access layer to our data? What if we could have an API right at the database level?
That is enough.
Who is this?
Stop this madness, or I will clear out your intestines.
You don't sound very intimidating. Who are you?
I am Sith Lord Darth Alpaca A3LPC, and I'm your overseer.
Well, you don't look very intimidating either.
Shut your mouth. I'm here to assure that you are doing what you're supposed to do, and not to fantasize about some crazy ideas. Who in their right mind would think about business logic in the database? Databases are stupid, boring, full of dependencies, and you cannot change or unit test them.
Sorry, my Lord Sith, but that is not true.
You are forced paid to make sure this particular part of the Death Star database works. So whoosh, do your quality improvement magic. I will oversee it.
Yeah. You really put me off the stride now, sorry.
You were talking about 3 ways to test a database. So far, I only heard about 2, and they were not very convincing.
Oh, okay. So let's then have a look at the actual data in the database, right? Because the purpose of a database is to hold data. So the most important thing to test is the actual data validity. What do we have here? Okay, this is challenging. My Lord Sith A3LPC, sir.
What is it?
What is this?
The Death Star user data of our Imperial database.
This is not very well structured.
It is schemaless.
Well, looks more like clueless.
Careful, young developer.
But you see the problem, right? For example, here.
I see that you have a problem.
But I thought we were in this together and would solve that together.
Can you fix it?
Yes, I think I can.
So?
Okay, then let's fix it. And step 1 to fixing this problem would be to identify. We need to find all the problematic rows in our data table, which means all the rows that have the same name. There should really be only one Darth Vader here because the guy is pretty unique, right? So how could we find these problematic rows? Yes, and maybe you already expected that a little bit. Of course, we use SQL. And here it is. And if you and SQL meet regularly, maybe you become friends at some point, which would be awesome. So what do we have here? We select the name and the count from our table Death Star users, and we group that by the name, but only return the entries that have a count greater than 1. And this will return the following result. Darth Vader with a count of 2. Not that complicated, right? I think even an alpaca could do that. But if you remember, we have 3 problematic rows, but the third Darth Vader has a different case. And so let's tell the database to ignore the case by transforming everything to lowercase first. Since we're grouping by name, we also need to add this lower functionality to the group by clause. We now get the full count of 3. Now, to actually get all the problematic rows that we want, we can now use this grouped result set as some kind of parameter. We don't need the count anymore, but now we can use this and put another select statement around it. And this will now return all the rows that have a lowercase name, which have a grouped sum that is greater than 1. And it will lead to this result that contains actually all the rows we are now looking for. And this is the beauty of SQL, and I can highly recommend to get friends with it. So now that we identified the problematic data, we can move one step forward and correct it. And in cases like this, we will need to talk and to collaborate with people who actually know the business context. We really need someone who knows whether Darth Vader earns 10 or 15,000 credits. And to make communication easier, it is very, very helpful to present the problematic data in an easy to read way. And there is one tool that is really a superpower in that regard, which is Excel. Because most database IDEs allow a very easy export to Excel or at least CSV, and most people are able to use Excel very instinctively. After we clarified which data is correct, we can again use SQL to fix it. And for this is a little bit more code. We'll skip it for this talk, but you can look it up in my blog. And as a bonus, there's also an example that shows how to easily get the Excel corrections from the actual experts back into the database, no matter what database you are using. So you might want to check it out. Now we have identified and corrected the invalid data. And of course, we could now run the identification query and the correction query again and again. But what we really want is to prevent our data to become invalid again. And luckily, the relational databases provide functionality to support us in that task since half a century now.
One moment. You aren't suggesting to add schema to the database, are you? We are schemaless.
I was going to suggest exactly that.
But we don't need this.
Sorry, but we just noticed that we actually do. Because garbage in that case means garbage out. We really want to prevent garbage from getting into our system in the first place.
Yeah, sure. That's done at the API level.
Oh, cool. You mean something like that, right?
Yes. We handle all the validation logic in the API. Even our REST endpoint and a very special command line interface point to the API.
Okay, that sounds pretty cool. I have one question. Why do we have these crappy entries in the production database?
Well, maybe there was this migration from a very old legacy project. And we had this intern. He typed in all the information from the old paper files directly into the database.
Okay, I see. But you would agree that it's probably a good idea to prevent the problems at the level where they occur?
Don't you be so cheeky. But can we?
Yes, of course we can. And what we need here is something that is known as a constraint. In the case of our multiple Darth Vader entries, we need a unique constraint on the name column. And if we add such a constraint to the database table, an error will be thrown whenever we try to enter the same name twice.
Darth Aura hates errors, so I'm not sure if that is actually a good thing.
Okay, but I can imagine that Darth Aura even more hates erroneous data in the database.
You'd be surprised.
Okay, anyway, let's assume for a moment that we actually care about the validity of our data. And in that case, we can use the same technique as we did during identifying the problematic rows and have a unique constraint on the lowercase value of the column. And with that, no combination of Darth Vader can be entered into the database twice. Now look at how beautiful our data is. Just one Darth Vader. But I guess that you already noticed that we still have a couple of other problems, like here, here, and here. All of them fall into the same category. Our alignments should be either dark, neutral, or light, but never bright, even if it has a similar meaning. And prisoners should never be prisoners. These are business rules, and we really want to enforce them at the database level. Because if our business rules are not in the database, it's really just a recommendation. And the great thing is that we can enforce these business rules right at the database. And this time with one of the very fundamental features of the relational model, data normalization and a foreign key constraint. And to do this, we extract the different values for alignments into their own table and add a unique ID. And we do the same thing for the rows. And as a next step, we then replace the alignment and role columns with in our original table with new columns that only hold the respective key. And no worries, we can easily reconnect them when we query the database. And this is called a join. Don't be afraid of joins. They are not that complicated. To make absolutely sure now that nobody can insert invalid IDs or something, we can add a foreign key constraint. And I prepared a complete example of identify, correct, and prevent this type of problem on the blog, so you can easily read it there in more detail. Now we have the same value for all the same alignments and roles. Isn't that beautiful? But we're still not completely done because we have a couple of problems with the salary. For once, we have values that are not actually numbers. And that gets a little bit complicated when we want to start aggregating or calculating them. The other problem is that there are negative numbers, but salary should never be negative. Yeah, maybe some managers think, but in general, these should not be negative. And both things can again be prevented right at the database level. At the moment, all of our fields seem to be some kind of strings, and that might come in very handy during development because we don't need to think about data types and all that stuff. But if we want to calculate with these values, we really need them to be numbers. And all relational databases allow to enforce exactly that. And some databases would even allow us to say, we expect here an unsigned number, which automatically would throw an error if we try to add negative numbers. But even if your database doesn't support that, there is another very powerful tool, which is called a check constraint. And with that, we can make sure that the salary is always greater or equal to 0. Again, we can identify, correct, and prevent these kind of errors, leading to a much cleaner data set. If we now look at the data, we have unique names, consistent information about alignment and roles, and we are even able to do salary aggregations very easily. We are now in a situation where we can prevent garbage to enter our database in the first place, which immensely improves the quality of not only the database, but also of each application that uses it. We prevented a lot of potential errors from happening, and I think that's quite an achievement for this morning. If you want to know more about the power of database validation, check out my blog. I will put there an example where I combine different constraints to make sure that there is only one boss at all time. For example, a specific alpaca. And if you happen to use an Oracle database, you might want to check out utplsql.org because that's a framework that really embraces these kind of checks directly at the database level.
Sam?
Yes, my Lord Sith A3LPC, sir?
This doesn't look as bad as I thought it would.
Well, I will take that as a compliment then.
But I have a question.
Okay, I expected that a little bit.
Can we do this in MongoDB?
No!
That is fantastic. I was laughing out loud several times here, and I learned a lot too while doing this. Really, really good. But what if the archives are incomplete?
Which archives?
The database archives.
Oh, they are usually not complete.
No, they're not.
So
you're not a very huge fan of object databases or NoSQL databases.
I am a big fan if they are used for what they are meant to be used for. I'm not a big fan if they are used to replace relational databases, because as we see, for example, with MongoDB, they started without transactions. After a while, they tried to put it back in. They started without schema. Now we have Mongo schema. There is a reason for that, right? So.
Okay. Yep, I see that. It was really good. I have to look into the UTPL SQL as well, because it sounds promising. And I really love the concept of being able to roll back for each unit test. I haven't tried that in that manner before.
Yeah, also feel free to reach out. I'm very approachable via Twitter or email or whatever. So feel free.
I feel my SQL skills are lacking a bit, so I'll definitely look into your blog as well. Do we have any questions from the audience? Have you found any Gherkin syntax frameworks for SQL, like the given when then syntax?
What we usually do when we use UTPL SQL, we use arrange, act, assert, but that's really up to the implementer. I don't know of a specific framework that uses Gherkin to target databases yet. But
just asking because putting the business rules into the database would mean you have to discuss with business about the rules as well, and verifying them. Yeah.
Well, it can still make sense, but what you usually would like to do is implement them in case of constraints then. So if you have some business rules, it's usually a good idea to have them implemented as kind of constraints, and you can even use triggers for very, very critical rules that should be enforced at the database level.
Yep. I'm really glad the Lord beside you is not that intimidating, because straight at me. So there's a lot of discussion in my community about how to test data warehouses, because it's a lot of SQL in the way of it's testing the input because there's always some kind of transformation of the data going on with the inputs. Do you have any recommendations for data warehouse testing or quality assurance of data warehouse data?
I have some general tips for that, and the first thing is look for input and output, because everything is always input versus output. And what you then can do is try to write automated tests that ensure that this is working small scale, because you don't want to test that big scale, because it's just too time consuming. And there is someone from the Oracle community who is very much into data warehouse, and her name is Jasmine Fleury. I can share the name. She does a lot of automated testing in the context of data warehousing, also with UTPL SQL.
Great, that's a good name to remember. I wrote it down actually.
Yeah.
Okay. Thank you very much, Samuel. Unless there's anyone else from the audience having questions, we'll leave you to your things for another 3 minutes before Raluca is coming on.
Yeah. Thank you very much for having me.
That was really, really, really good.
Yeah, thank you. Thank you.
Would you mind writing the name of Yasmin Fleury in the chat?
Yeah. Just let me make double sure that because the last name is a little bit
A little bit French.
that I have it. Yeah, okay. It's Jasmine Fleury, and this should go to everyone. And her Twitter handle is Jasmine Fleury. And yeah, I would very much appreciate some kind of feedback, because that's really what I'm thriving on. So if you have something to say, positive, negative, doesn't matter, please reach out, Twitter or email or whatever.
I'm very certain everybody was finding this both interesting and amusing as well. It was a really nice, what do you say, way of performing. It was a performance as well. It was a good show and a good opportunity to learn. Thank you very much.
Thank you. And have a great rest of the conference then.
Yes,
thank you very much.
You feel free to stay if you want to. Although I'll be stopping the recording now because Rick don't want us to record her presentation, so I won't do that. So I'm stopping the recording.